All right, let's talk about something that's literally all around us, all the time. It's invisible, but it has this incredible power to affect our health and, the entire planet. Today, we are going to break down the science of air pollution, what's really in it, what it's doing to us, and what it actually takes to clear the air.
So let's just kick things off with something that is, well, it's pretty shocking. For millions of people, say in a city like Delhi, the simple act of breathing, just walking outside, is basically the same as smoking 10 cigarettes a day. I mean, that's not some far-off environmental problem, right? That is a real personal health crisis happening right now, driven by a perfect storm of traffic, industry, and even stuff like seasonal crop burning.
So what even is air pollution when we get right down to it? Well, at its core, it's pretty simple. It's what happens when we introduce harmful materials into the Earth's atmosphere. And these aren't just, minor annoyances. We're talking about substances that can seriously poison plants, harm animals, and have major consequences for our own health.
And the things causing all this trouble, we call them pollutants. You can just think of them as the specific, nasty ingredients in a toxic recipe for our air. They're the substances that just plain don't belong there, and they are the direct cause of the whole problem.
Okay, so where is all this stuff coming from? Well, nature does play a part, for sure. You've got volcanoes, forest fires, all that. But, and this is the really important part, that's just a drop in the bucket. The overwhelming crisis that we're facing today, that's driven by us, by the exhaust from our cars, the smoke from our factories, and the fuels we burn. All right, let's get a little more specific. Who are the main culprits in this atmospheric crime scene? It's time to name some names and meet the key gaseous pollutants we're really up against.
This list right here, these are the heavy hitters. You've got sulfur oxides from burning coal, nitrogen oxides from our cars, carbon monoxide, methane, the whole gang. These 5 categories, believe it or not, account for over 90% of all global air pollution. Yeah, they are without a doubt our biggest problem.
But see, these pollutants don't just float around in the air doing nothing. Oh no, they kick off this huge, messy chain reaction of environmental problems, where one thing leads to another in a pretty devastating way.
The first and probably most obvious consequence is smog. You know that thick, soupy, brownish haze that just blankets major cities? That's it. And it isn't just ugly fog. It's a toxic cocktail that irritates your eyes, makes it hard to breathe, and can be a real nightmare for anyone with asthma.
And then you've got this problem, which starts with invisible gases, but turns into a very real threat. So here's how it works. Factories and cars pump out stuff like sulfur and nitrogen oxides. These gases float up. They mix with the water and oxygen in the atmosphere, and they basically do a little chemistry experiment up there. And then they come back down to Earth as acid rain.
And the damage from acid rain is just widespread. It makes soil infertile, which is terrible for forests and farms. It gets into lakes and rivers, making them too acidic for fish to survive. And it even physically eats away at our cities, slowly dissolving buildings and historic stone monuments.
And the danger doesn't even stop there. A lot of these same pollutants are also doing double duty as greenhouse gases. As you can see here, things like carbon dioxide and methane build up in the atmosphere, and they act like a heat-trapping blanket around the planet. It's literally the engine behind global warming.
Okay, now let's zoom in on one pollutant that's especially dangerous because you can't see it, you can't smell it, which is why it's earned the name the invisible killer. I'm talking about carbon monoxide.
So what is it that makes this one gas so incredibly deadly? Well, the answer isn't about what it does to the atmosphere. It's about what it does directly to you, inside your own bloodstream.
To get this, we have to zoom right into our own bodies. So imagine the hemoglobin in your red blood cells is like a massive fleet of taxis. Their one and only job all day long is to pick up oxygen from your lungs and drive it out to every single cell in your body. But then along comes carbon monoxide. And it doesn't just cut in line, it hijacks the taxi. The CO molecules jump into the hemoglobin, they kick the oxygen out, and then they refuse to leave. This creates a massive biological traffic jam, and it literally starves your body of the oxygen it needs to survive.
And here's the crazy part that makes it so dangerous. Your hemoglobin is 200 times more attracted to carbon monoxide than it is to oxygen. 200! I mean, think about that. That incredible magnetic pull means that even a tiny, tiny amount of CO in the air can have a catastrophic effect on your body.
Okay, I know, that was pretty heavy, but the story absolutely does not end there, because once you understand the problem, you can start to solve it. So let's switch gears and talk about how we can actually fight back and clean up our air.
A huge piece of the puzzle is just making smarter choices about how we power our lives and get around. This means switching to cleaner fuels, moving toward electric vehicles that have zero tailpipe emissions, and just using things like public transportation more often. We also have some really powerful technology on our side. Inside pretty much every modern car, there's a catalytic converter. It's basically a little chemistry lab in your exhaust pipe that turns the most harmful gases into much safer ones. And for big factories, we can use scrubbers that use a fine mist of water to literally wash the pollutants out of the smoke before it ever leaves the smokestack. So in the end, the science is crystal clear, and the solutions, they're actually within our reach. Air pollution is a problem we all created together, which means the solution has to be something we all do together too. So the final question really isn't about the science, it's about our part in it. What's one change you can make starting today?